Imagine yourself as the only doctor available in a hospital, and you have to treat three patients, but the thing is, you can only treat one patient at a time. And so the first patient comes to you with a very high fever. You say, okay. Then the next patient comes to you with the hand fracture. And then the third patient comes to you with a severe head injury. So what will you do? Will you apply FIFO principle, that is first in first out? So if you apply FIFO, the person with the high fever should be treated first. But practically this is not the thing here. The person with the severe head injury must be treated first, must be treated on priority. So this is where the priority queue comes in play. So when the first patient with very high fever came to you, you said, okay, you are welcome. Now, the moment when the patient with hand fracture comes in the priority queue, you say, wait, this patient with hand fracture has more priority than you. So, what you do is you just shift behind and let him be in the priority. Okay. So, now the person with the severe head injury enters the queue. You say, wait, this patient has more priority than this patient. So, what you do is you just go behind and let me go ahead. Again, this patient has more priority than the fracture one. So what you do is let me go ahead and you just shift behind. So now this is the correct order as the patient with more priority is in front of the queue. So now you will treat the patient with more priority, and this is exactly how the priority queue works. You are given some task and based on their priority, you align them in a queue. As simple as that. In Python, we implement priority queue using heap data structure. So a heap data structure is nothing but it's a complete binary tree, and a complete binary tree we can say that is a special type of binary tree in which all the levels are filled completely except the lowest level node. But no need to dive very deep into it. Just understand heap with the analogy I gave in the previous example of a doctor and the three patients. And now the heap is classified into two parts, which is Min-Heap and Max-Heap. So in Min-Heap, the parent node is always smaller than the children. So we can see that the value of the parent node in every part of the binary tree is always smaller than its children. So when we will implement a heap in Python, so we will see that by default a heap is always a min heap, which means that the task with the lowest value will be given highest priority. Then we have max heap in which the value of the parent is always larger than its children. So as you can see in this example, that every node, a parent node of this tree is larger than its children. So far we have discussed what is priority queue, what is heap. So now we will implement priority queue using heap. So for this, what I will do is I have taken some task and assigned a priority to them. So here I have taken a task eating and assigned the priority 1. I have taken task sleeping and assigned priority 2. And I have taken task studying and assign priority 3. So as we know, by default a heap is a min heap. So the value with the task with the lowest value will be given the higher priority. So now what I will do is from heap queue I will import two methods which are heap push and heap pop. So the work of method heap push is to push the task in the priority queue, and heap pop will remove the task from the priority queue. So what I will do is I will create an empty list called priority queue, and I will use the method heap push to push the task into the priority queue. So I will be pushing the task into priority queue, and in a tuple, I will give first the priority of that task. So for example, we will be pushing the task studying in the priority queue. So I will give the priority 3 and then name the task. So the task is studying. So let me show you. If I print the priority queue and run it, so you can see the task is appended in our priority queue. So let me append the remaining two tasks. So I will push in the priority queue. So what was our next task? Let me see. We're sleeping. I will assign the priority 2 and task will be sleep. Again, I will push one more task in the priority queue. which will be of the highest priority, that is 1, because we know that by default a heap is a main heap, and the value and the task with the lowest value will be assigned higher priority. And just a second, what was our third task? Okay, our third task was to eat, and which has a higher priority. So now if I print the priority queue, so you can see our priority queue is printed. So even though I pushed the first task as studying, our first element of the priority queue is eating. So this is how basically a priority queue works. It doesn't follow FIFO principle, that is first in first out. It works on basis of priority. The element with highest priority is at the front of the queue. So now if I want to pop the element with the highest priority, I will just say heap pop. And if I run this, okay, I will also print the queue, priority queue. So you can see the element with the highest priority was popped out. So priority queue is basically used in the problems where we require the shortest path, and also in the algorithms like Dijkstra's algorithm, A star algorithm, or best first search algorithm, where shortest path is required. And that's all about priority queue. So till now we have covered all the prerequisites that we would have required for phase 1 of uninformed searches. We have covered stack and queues. We have learned how to implement them using tech. Then we have learned about trees, binary trees. Then we have also learned about graphs. And now we have learned about priority queue and heaps. So these were all the prerequisites that we would be requiring for uninformed searches. So that's it. And in the next video, we will be starting with our phase 1 of uninformed searches, and we will be learning breadth first search algorithm and also implementing it in Python with dry run and all the code explanation. So that's it for today. Thank you.